Okay, so that was memory piece, right? So let's go back here, and now let's do some code. We'll introduce some code, and then we'll see, well, how is this code, how can we use this code to show like what's happening with the stack, right? We'll be using the stack exclusively, and we will not be using heap not until we get to strings, right? So I don't think we talk about strings today. Maybe in the next lecture we will, and I'll show you how the heap and stack work together to display or load string information, right? So let me go here. Okay, so last week, I think this was the last example I created, right? Like I created a function that simply just echoes a variable, meaning like you use this function, you call this function, whatever number you send, it's just gonna be like, okay, I'm gonna send it back to you. Okay, so that's fine. And we used int, right? So int means like whole number. As I was saying, the book talks about a lot of different data types, but in this class, we're not gonna go crazy and try to understand like all the data types. That's just too many, right? Like, you can always Google that stuff. So here we'll only use, in this class we use integers. Those are whole numbers. And then we use double. These are decimal numbers. And then we use character. That's just one character, like the letter B, right? That's one character. And then we'll use string, which is a special data type. It's a sequence of characters. For example, like C++, right? That's a sequence of characters. That's it. Like, I'm not gonna like quiz you on like what's a long integer, what's a long integer, what's long. Okay. I mean, because really, like, you can find that information on the internet. We're interested here is like, how do I use what I learned in programming 1 and C++, but more importantly, how do I use that to create like some useful program, right? Like, how do I use conditional statements, loops, and functions, and that to create something? That's what we're going to learn in this class. And then how does it work with memory? Okay, so that's why like I'm not really worried about like all the data types. You can always Google that, and if you go work somewhere, rest assured they're going to tell you like, okay, like maybe we can narrow it down to these two data types, which one should we use, and there's some research done as to which ones to use, and then the data types are used, right? So I'm not gonna quiz you on that. It's more important to learn like basic programming methodologies here. Okay, questions here? So right away you should be like, hey, wait a minute, like in Python, I knew about whole numbers and decimals and characters and strings, but I just create a variable in Python, and then like Python takes care of the rest. C++ is not like that, okay? With C++, you have to tell it, okay, I'm going to create a variable, and this is the data type that I'm going to use for this variable. That's just how it works in C++. Okay, so it's a very what's that word? Very explicit. Like you have to like baby it. Okay, so let me go to some code, and then we will. I think I need this one. We'll diagram it to understand how it works. Okay, so let's see here. We introduced the integer. Let me see what the code looks like. We just returning. I'll purposely just slightly modify this because I don't want to create like a whole new program. And I'll say like create a variable. I'm going to create a variable, right? So create an int, or that's whole number, variable. And I'll say, okay, let me say integer return value equals this value here, num, plus I don't know, whatever, right? Plus 1. I'm just trying to show you, like, this is how we create one variable. So now, like, if this value would be 5, then we would say return value is 5 plus 1, so the return value will be 6. Okay. And if we run our test case will fail, right? Because we've modified the code. But that's what test cases are meant for. Remember, how do we work in this class? We write code, then we test our code. So I modified my code, so now I better go back and see if my test case still works. We know it won't work, right? But I still want to demonstrate that. So we go here. We have this test case here, where we're saying that if we echo variable with 10, then it'll be like 10. So let me go to CMake. Oh, well, like, see the icon? It's not, I don't see the icon, but it, like, I guess it's still there. So let me go here and go to examples, data types, running terminal. That's how we run programs in C++. So notice, like, it's telling me that I'm wrong, right? But that's what test cases are for. So you don't have to worry about, like, modifying code and then, like, well, you know, you cross your fingers and I hope it didn't break my program. Here it broke my program, right? So right away, very simple example, but I'm showing you the value of creating a test bank. You only have one here, but eventually we'll have a test bank of cases that's always, like, working as a protective harness for your code, right? And that makes you a better programmer because it's helping you produce high quality code, right? So let me go back here and go back here. And what I want to do, I know the example doesn't make sense, right? Because it's echo variable and it's kind of like, hey, really? Are we echoing the variable? No, we're not. But I don't want to create a new program. I just wanted to create one variable, and then what I'll do is I'll be like, okay, I want to show you how this code and this code here maps to the stack. How are they related? How are we going to be tracking, like, well, variables, or every line of code that I write goes onto the stack? How does that stuff work? Okay, so this is how it works. So we have main here, right? So we already know what echo variable does, right? And so I'm just going to copy this here into any page. And then we're gonna map it to the stack. So what do I mean? So we're gonna see how it would look on the stack, right? So we have stack, and heap will always be available to our program. In this case, we aren't using it, but I'll always put it up here just to show you that it's available, right? So we have stack. And we have, like, some x100 number, right? Meaning x, meaning, like, it could be like any memory address on the computer, right? So this is one address, this is another address, another address, right? So we're just gonna assume x means like some large number, and 100 and then 96, right? So it's kind of like, hey, wait a minute. Why 96? I'll explain that in a little bit. But for now, how does this code map onto the stack? Okay, that's what we are interested in. So we go here. Let's change some color. So we go blue here. So when I introduced the stack in the previous example, I said main or functions are loaded onto the stack. Main will always be the first function that's loaded onto the stack. So that means main gets a block of memory. And I'm just going to assume that it got maybe like this block of memory. It got 1, 2, 3, 4 memory blocks, okay? And then I'll label it here main. So meaning this block belongs to main. And what do we put in main? Well, any variables that are in main. There's no variables in main. We have some value here, 0. So maybe 0 would go here, right? Why 0? With some value, some code, so it has to be mapped onto the stack. And this would also be mapped to the stack, but it would make our diagram too complicated, so we are not going to worry about that. Instead, we are interested in this one here, echo variable. So we're like, okay, so how does echo variable come into play here? So let me go here. Before I go on, what I'm going to do is I'm going to run the program, okay? I'm going to run the program, and then we're going to be like, okay, I think we know like how this stuff is working. So let me jump back to the program. We have main here. So we have to go into src hello world data types int ex0101 xe, right click, run in terminal. Let's run it. So 11, okay? So we're like, oh, 11. So what happened here? Okay, main was loaded onto the stack first. And then echo variable is called. So is echo variable also loaded onto the stack? Yes, it has to be loaded onto the stack because every line of code we write has to be loaded onto memory, right? Stack is part of memory. So then we're like, oh, so it is loaded onto memory. So what happens when echo variable is loaded onto memory? We're like, okay, well, let's see what echo variable does to begin with. It has how many variables here? It has one variable in the function, so that's a function variable. And then it has one parameter. But if you really step back and think about it, a parameter is basically a variable, right? We just call it a parameter because it distinguishes it from a variable, but it does the same work, right? What do I mean? I'm saying here, echo variable send in the value 10. Okay, so I'm like, okay, send in the value 10. Where will the value 10 be assigned to? It'll be assigned to this variable here, or this function parameter. So this will be 10. So in essence, it's a variable. If I had send in the value 15, then this value would be 15. So in essence, it's like, oh yeah, it is a variable, but we call them function parameters, okay? And then we have another, so this one's a function variable, okay? So knowing that, then we're like, oh, okay, so we need to load echo variable onto the stack, meaning show on the stack how it's loaded, and then make room in memory blocks for num and for the variable return value, and then for the return statement. Okay, so let's go and see how that would work, right? So we're like, okay, so I just told you that echo variable is loaded onto the stack. Where will it be loaded onto the stack? Remember, sequential. So it's like, oh, the next available block. The next available block is this one. So then let's assume that we got 1, 2, 3, 4, 5 memory blocks, right? So then echo variable is loaded onto the stack. And then we have a parameter, which is a variable. I'll write the name here so that we can keep track, right? So num has what value? 10. So num has value 10. And then there would be, so what I'm doing here, like this may not be exactly how it is in memory, but conceptually we should be like, okay, I understand what's going on here. So then we have another variable, return value, and return value is the value of num plus 1. So then we're like, oh, so then this one has value 11. And then the return statement, right? So the return statement value 11. Okay. Why are main and echo variable in memory? Because that's how our program runs, right? Like we need to load functions onto the stack. Let me see if there's a question. Okay, I'm not understanding your question. Why are we doing in two windows int and main? I'm not sure I understand the question there. Okay, so program starts running. Remember, main is always the first function that's loaded because that's our program start. So main's loaded. And then when this statement executes, it's like, hey, load echo variable onto memory or execute it. So it's loaded onto memory. Let me do this here, right? So that one's loaded onto memory. And then the variables or the data has to be also loaded onto memory. So we have integer, integer, integer. Notice this is not used because we are not using strings and we are not using list, right? So we're like, oh, okay. So then as soon as echo variable returns this value 11, right? So it'll return it here and then is displayed. So as soon as that happens, this block of memory or echo variable is removed from memory, and this block here, it's available for reuse. So our program can reuse it. That block of memory can be reused. Excuse me. And if we go back here, then it's like return 0. Return 0 is returned. There's no more code here, meaning main's already finished executing. So our program's going to end. So main is also removed from memory. And that whole memory block, this memory block here, is somewhere in here. So then, assuming this was the hello world program, then this is also removed from memory, and then it's available for Windows to be, Windows can give it to some other program, right? So that's what's happening here. So let me jump here, and now I will stop and ask if there's any questions. Okay, so no questions so far. So then what I'll do here is I'm gonna stop.